So following up to our Solid Start app, this time we're going to add logic to our login form. Cookie session storage, password encryption, and protected routes with a database, of course, and that's gonna be a lot of code. So let's get right into it. Hi, I'm Attila, and I've implemented my share of CRUD apps, to-do lists, and whatnot. Implemented row-level security on multi-tenant databases and such, and though sometimes because we use them all the time as proof of concepts and etc., there's a reason for that. They are very good contrived examples of real-world apps, which means that they're great benchmarks of developer experience in frameworks. So today, we're going to do it with Solid Start. The external dependencies will be NanoID to generate unique IDs to our users, bcrypt to encrypt the passwords before we store them in a database, and the Xata's client is going to be the ORM of choice, so we can connect our app to the database. Besides that, there's already Zod in there, so we're still going to use Zod, of course, but after this data handling stuff, everything else is going to be handled by Solid Start itself, so no big external dependencies. So let's just jump right into the code. So as you can see here, we have the app we wrote before, and it's actually not doing much stuff. So I'm actually going to stop the development server so we can add our dependencies. So it's going to be bcrypt, NanoID, and the Xata client. Now that we're ready for it, we can just close up the terminal and open up our schemas. So we actually need to now add our Xata access token to our environment variables schema, so Zod can actually validate that. And with this, every time our server is running, we're going to have this validated. And now we have a few more schemas. As you remember, we created the login schema and the login form schema. So now that we're actually pushing them to the database, we need a version of that data that has the IDs. So we're going to create a full user schema, and that's going to extend the user login schema to have an ID. And once that is done, there's another one that we are going to need, which is actually a type. So I'm going to create a type for our user login form. And this type, I'm actually going to have Zod to infer it from the type of our user login schema. And that's it. Our schema is now done. We're ready for it. We can start validating the data that we're going to send to the wire, through the wire. And now we can actually link our code to the database. So to do that, we actually need a Xata CLI to create a codegen link to the workspace and so on. So that's going to end up creating for us a Xata RC that has the link to our database. And the init is actually going to push the schema that we already have established here for now, which is just the table, the users table. And that's going to also generate the codegen. It can even install the dependencies if you want. So I have this already set up in this project. So the link, the GitHub repository is linked on the description. So you have the codegen in case you already have it initialized, or if you decided to initialize it manually, and you have a link that's going to push this schema and is going to also put the codegen in the right place. With that done, there's the last part we need to do, which is this creating the secret. So with the secret, you can just come over here and run the OpenSSL and generate a random hex string, and with that you can put on your .m file. And so once all of that's done, we're ready to start our project again. We can come over to the Xata codegen, and that's going to then have all the tables done and create the SDK and so on. So now we're ready to start playing around with our app. So with this now, we can start coding our session. So I come to source, lib, and I'm going to create this auth just to split all the files that belong to that. And I have a DB and a session. So in the session, that's where we are going to code the logic that's for our session to be created, to be stored, and to be destroyed. The most important thing is to generate the session cookie. So with that, I'm going to call it storage because I'm going to store the session in the session cookie. And this is going to use this helper from solid start session, which is pretty similar to Remix. If you look at here, there's even a mention in the source code. So if you're coming from Remix, you'll find it extremely familiar. Now I pass the cookie. The cookie I can pass whatever name I want. It's going to be secure because I only want it passed through HTTPS connections. The secrets I'm going to use is that session secret that we just generated. The same site is going to be lax, which is also the default, but it's good to be explicit about it. This means that the request is coming from an external site, so navigating from an external site. We're only going to send the cookies if it's a GET request. So that's that's a good degree of security and also providing a nice user experience. So if the user is actually navigating from outside and they have a valid session in the browser is able to actually tell our servers that that's happening. The path we're going to pass is the root because we want this cookie to be passed on requests throughout our entire domain. You could then just have something like, I don't know, I just want it to be passed by dashboard or something like that. So you can do it. The max age is going to say for how long it is valid. And lastly, we can set the last definition to be HTTP only. So this means that our cookie is not accessible through JavaScript. This is a very good cross-site scripting protection. So with that, we have our storage ready. We can actually start coding our session. And in the spirit to make things a little bit drier, I'm going to create this get user session function that's just going to take a request. So the request in solid start are a regular node request. I don't even need to add. It's going to be added by TypeScript because we defined node as one of the libraries that TypeScript must have available. So it's a regular request interface. And with that, I can just call up the storage that I just defined and get the session by passing the request cookie. And with this, I'm able to just with the request object, I can get the user session back. This makes my life easier when we're about to start retrieving stuff. So for example, we're going to create this other function to create a session. And this function is getting a user ID, which is going to be string, a redirect to, because if the users try to navigate to a protected route, we're going to push them back to the login. And then once they log in, we actually want to resume whatever we were doing. And obviously we also need the request in this case, because the first thing we're going to do, get the user session, the method we just created, and then we set our user ID as the user ID of the session. Once this is done, we can then use redirect, which is a method from solid start server, and then we redirect the user back to where they wanted with the additional header that is our new committed session. And that's it. That's how we create a session. So mind you though that this is implying that we already authorized the user. So this is actually going to be on our database that we're going to do. So the database method is actually going to call this create user session. And if we can create a session, we need to also be able to destroy a session. So to destroy the session, we again need to retrieve it. So we get the user session and then we assign it to a destroyed session, and then we can just return it. And that's it. So now we're able to handle our session. We create and we retrieve and we end the session. So we're ready to now integrate to our database. Now we go to the inside our auth folder, we go to the BTS. I already have here bcrypt and NOID. And I can actually uncomment all this because now we already implemented these methods. So the first thing is actually going to retrieve my Xata client. So this is actually coming from the code gen that we generated. So the first thing we want to do is being able to retrieve a user. I want to get the user by their ID. So by passing the ID to the user, I'm going to try to get it and then return parse. So this is Zod actually validating that the data that's coming from my database is exactly what I expect it to be. This is going to allow me to get a little bit better type completion and some errors. And now I'm going to call all my users and I'm going to filter them by the ID and I'll get only the first one. In this case, because it's a very contrived example, if parse fails, it's actually going to throw an error, and I'm going to return null in this case, which is I don't have a user. Like, ironically enough, it's the same thing that Xata SDK would return if I try to do this and the user doesn't exist with this ID. But yeah, it's good for some consistency. Since it's a contrived example, you can build on top of it. Also, I have another unique identifier for my users because the username is actually an email. So I want to also be able to retrieve my users by their emails. And now it's the moment that we need to create a user. So I'm going to pass here the user login form as the object of the user, all the data that's the user is being sending through the form. And I also need a request so I can actually start the session, and the redirect to is going to default to the root. So if the user is not was not in any other page, we just send them back to the route and let our middleware take care to put them in the right place in a moment. So now I'm going to pause this form because I want to make sure that this is going to be okay. I'm passing the safe parse so it doesn't throw on me. And now if my parsed form doesn't have a success, then I can control this error. And here is a moment where you would be able to put some logic. So here are like 3 different patterns that we can deal with it. So the first one I'm calling the full parse one. That's gonna throw an error if the parse is not okay. Then in this one, I'm not parsing at all. I'm just trusting my ORM because I know it's going to return null. And lastly, I use the safe parse, which doesn't affect the runtime, but then I get this object that has a success or not, and then based if it's not a success, I can handle whatever I need. Now I know I have a user that I might have a user that exists. So because I have the user email, now I can try to retrieve it. And then if I have an existing user, I like to coerce it explicitly. So I turn it into a Boolean, and then if I have something, I can say, yeah, you cannot register. But finally, this is like our happy path. If the user already exists, now it's the time I push them to the database. So first I need a hash of that password. So let's have bcrypt hash my user password with a salt. And I can just pass the defaults of the salt. And now I have my stored users, which I'm going to parse whatever is coming from Xata to make sure it's all good. And then I'm passing the ID, and I'm going to set the nano ID by hand. And finally the user and the username, and the password is going to be the hash one because we don't send passwords the wire and we don't store them as text. And finally I can create a session with our parsed user ID. Not parsed, sorry, with a stored user ID, whatever redirect to was passed, and with the request. And just like that, we register the user. Now that we're able to register, we need also to be able to sign in, right? We're going to export a sign in, which is also going to be an asynchronous function, taking the user login as the user login form and the request. And again, the redirect to is going to be an optional parameter that defaults to the root. So now I take the username and the attempted password with the user login. I'll take the user, if it exists, from get user by email, passing it the username. And then this is the moment that I need to confirm first if I have a user. So if the parsing was a success, which means I got an object that has all the user data that I need, I continue. If it's not, I'll just return null, so the user was not able to log in, and I can handle it later. Otherwise, I need to check if the password's correct, so I can just use bcrypt for it. They have a method called compare, which the first parameter is the string you want to compare, and the second one is the encrypted version of it. Now I have the user that came from my database, and I retrieve the password from the data, and I compare it to the data that the password that the user entered. And then if the password is not correct, I can just say no, you cannot log in, and handle it later. Otherwise, we create a user session again. with the ID of the user that we have, with the redirect to that we passed, and with the request. Awesome, this is ready. So now we can go back to our component and start adding the logic to log the user in. Awesome, so here we are in our index route. And we have our login action that we already started coding. You see there's a bunch of unused variables and 2 to-dos. So on the first one, for the login, we need to implement the auth and the sign-in method, which we just did. We just need to use it now. And lastly, in the register, we also need to implement it. And see that we have here this try catch. So all the errors that we've been throwing and we're not actually passing a proper message, what's going to happen is that whenever we catch it here, solid start has this form error. That's a helper from solid start data. And this is actually going to be able to allow us to pass, for example, on the reader, on the register, we pass which fields are wrong, and then we pass particular error message to each field. So let's get started with the login. So for the login, what we need to do is essentially just, instead of returning the redirect, which is something we're already doing in our DB method, we're going to return the sign in, and because it's inside the try catch, we need to await the return. So sign in, and we pass username, we pass password, and we pass the request, and we pass the redirect too. So we import it, all good. Sign in is done. And for the register, we need to implement the auth and the create user method. Same thing, await, because it's inside a try catch again, and we're going to attempt to create the user, and we just import the create user. Awesome. So now that we've done this, we have the login action done. We have all the logic using it. So we have the post request for the login action, and we have the render method. What's missing for us now is the route data. So to do that, we're going to create a server data. This is another helper from Solid Server, which is going to allow me to handle GET requests on the server side. And so the callback is an asynchronous function, which I'm not going to use the first parameter, but the second one is the request, which is kind of important for us because what we need at this point is to get the user session based on this request. Once I get the user session, if I have actually a user inside this session, I can redirect my user to the internal page. And if I don't, then I actually don't have any data to show them because it's just a login form. So this is actually what's going to make sure that if the user gets the login form and they're already logged in, they have nothing to do there because it's a pretty blank page. So I can just help them and just send them to the right route, which is probably what they want. Again, this is a very contrived example. So once this is done, I now can handle when the user is coming logged in to my root, and then I put them in the protected page. Now I need to handle when the user tries to access a protected page, but they don't have a session. Now we need to come over here to this entry server, which is where we handle server logic inside Solid Start. And this actually allows us to change some middlewares. So what I'm going to do here is create a new function. I take this forward, which is what as middlewares do. They just take a response and then they create a response and then they forward the response to the next middleware. So this, we can actually create more of these. So it's going to return this asynchronous function, which the first parameter is an event, and then I can just return the forward with the event. So at this point, this is just like a blank middleware doing nothing. We're going to implement some extra logic here. So for example, I'm going to create this protected paths array. So here's where I'm going to put all the routes that are protected. I have only one. So this makes my life easier at this point. And I'm just going to create this little checker to see if a route is protected. And this is just gonna very convoluted example. Yes. But then probably it's going to be useful to some of you. So now I'm going to check if my route actually starts with the path that I have in my protected paths. And if it is, I return true. If it's not, I return false. So then I can check if a route's protected or not. So with this, I can come back to my middleware and I can say with the request that exists inside the event, I need to import it. And then I take my user ID. I'm going to use the string that's coming inside the request as the URL. I create a proper URL out of it just so I can extract the proper path name. And now that I have the path name of the request URL, I can finally check if it is protected. And also, in case it is protected and I don't have a user, I can then redirect them to the login page. Else, if the path is actually the login page and I have a user, I can then redirect them to my internal page. And then as usual, I can just, if it doesn't catch any of these, everything's all right, I can just forward it. So this is a way, if I have another middleware later, I can do so. This is important to be like your first middleware because it's the one that's making sure your route's protected, so you don't get you want to reply that as soon as possible if the user is trying to access a protected path without having a session. So now that our users are capable of logging in and our routes are protected, we also need a way to let them actually get out. So let's log out. So I'm going to come to my components folder and I'm going to create this logout. And this component is going to use a create server action. Yes, you heard it right, server action. Solid Start has server actions for a while now, and they're stable and awesome to use. And we're also going to import our end session. So with this, I can export my logout component. And this component is actually going to use the second parameter that's coming from the server action, which is a linked form. So now I can create my server action, and this is telling my compiler that action is not going to end up in my client-side bundle, and it's going to be used exclusively on the server side. So this takes as the first parameter the form data, as the second parameter the request, and so it's going to return a redirect to the root, and the headers obviously are going to set the cookie to commit the end of the session. So now that our server action is created, what we need to do is add it to our protected route, which is in routes in the index. So in this route, what we have is the logout button inside the main. So because it's position fixed, I just put on top of it. And then we have the h2 that's getting our username that's coming from this route data, and then the link. So what we need now is to create this route data because I already know even what type I want it to have. So now we're going to export. So now I'm going to create server data, which means the request is going to happen only on the server. So I want to get the user session from the request. From the user ID that I have on the session, I want to get the user that I actually have. Lastly, I have Zod parsing that user for me. And then if the validated user has a success, I'm going to return the username. If it's not, so it means I don't have a valid user, I just send them back to the login and I return no data. So at this point, I can just use the route data hook and I strong type it so I know this is actually a string. So with that, we're ready to try on our app. So now as you can see, I have my database open over here, no users at all. This is my whole schema, and I can just come over here and say yes, solidsnake@gmail.com, and the password, remember, needs to be 6 characters, so 123 123. I ask it to register. I can do this as many times as I want. There's no re-render involved, so I know everything is right. So now I want to register it. I don't want to save. You see, it's already went inside, and if I update here, I can see my data inside my database. Oh, good. So I updated it here. Here's the hashed password. You cannot see it. Here's my username. So now I can log out, and let's try again. solidsnake@gmail.com 123 123, and now I want to log in.
Nice.
Awesome. So that was it. I hope it was not too much code and that you have enjoyed it. As usual, you get a subscribe and another one to keep watching, like pew, pew, somewhere around here. Subscribing is actually important because you'll be remembered when I publish something else, and then we can see each other again and so on. And as a nice byproduct, you make me happy and you keep track on this app we're building. So it's already the third video of this series. There's some other stuff that I want to play around, and I want to dive a little bit deeper on Solid.js soon. So remember to turn on the bell. And hopefully I'll catch you on the next one. So bye.